Hi, this is Mr. Alexander, and today I want to talk to you about logarithms. More specifically, I want to talk to you about how to expand, condense, and solve logarithms. So let's get right into it. When I say expanding a logarithm, what I mean is taking it from one logarithm and turning it into 2 or 3 or 4 logarithms. For instance, here, this is the log of x times y times z squared. Well, if I want to expand that, I can, because multiplication inside the parentheses is the same as addition outside the parentheses. What I mean by that is I can change this to log of x plus log of y plus log of z squared. Now, the reason I was able to do that is because there's a rule for logarithms that if there's multiplication inside the parentheses of one logarithm, I can expand that to more than one logarithm if I separate the terms by plus signs. Now I can simplify this a little bit further. Log of x plus log of y plus, because logarithms have another cool little rule. If you have a log of something and that something has an exponent, you can get rid of the exponent by moving it out front. For instance, I can move this 2 in front of the log of z. And this would be the fully expanded form of the original problem. Log of x plus log of y plus 2 log of z. On this one, I've got log of u to the 4th power divided by v. Well, just like multiplication turns into addition, division turns into subtraction. So I can rewrite this as log of u to the 4th minus log of v. Now I can simplify that just a little bit further. Because I still have that 4th power up there, I can move that out front. 4 log of u minus log of v. That is the fully expanded form of this original problem. Now let's talk about another multiplication problem. This is log of a times b squared. Well, first off, I've got a squared on the outside of the parentheses. I can go ahead and move that out front right now. So I can change that to 2 log of ab. Now I want to expand it into 2 logs. Since they're separated by multiplication, I'm going to change them to plus signs. So equals 2 parentheses log of a plus log of b. That's the fully expanded form. Notice how I had to use parentheses to show that that 2 distributes to the log, this one and that one. So if you want to take this one step further and do 2 log of a plus 2 log of b, that would also be correct. All right, one more division problem. So since it's division and there's a 4, I'm going to first move the 4 out front. So I'm going to make that 4 log of x divided by y. And now I'm going to expand it by doing 4 log of x minus log of y. Remember that division inside the parentheses turns into subtraction outside the parentheses after you expand it. Now I'll go ahead and distribute that 4. Make that 4 log of x minus 4 log of y. So part of what we did was we expanded logarithms, but we also condensed them, changing them from 2 logarithms into 1, or from 3 logarithms into 1, 4 logarithms into 1. As long as logs have the same base, you can expand them and condense them. If they have different bases, you're not going to be able to do that. So first off, I'm going to move that 4 back into the exponent. So I'm going to make this log of 3 to the 4th power minus log of 8 to the 4th power. See how I took those exponents and moved them from the front back into the exponent. Well, now I've got two logs that have the same base, they're both base 10, they're both the common log, that are separated by a minus sign. So I can turn that into one logarithm by making this log of 3 to the 4th power divided by 8 to the 4th power. Like that. And that's how you can condense them. And you could simplify this further by actually typing these things in your calculator. Or, even better, let's use our power table. So, 3 to the 4th power is 81, and 8 to the 4th power is 4,096. So, I can make this log 81 divided by 4,096. That's the fully simplified condensed form. Here, we've got log of 2 plus log of 11 plus log of 7. They all have the same base, so I can make them into one big log. And I'm going to do that by separating them by multiplication sign. So 2 times 11 times 7. And I can go ahead and do that multiplication. 2 times 11 is 22. And 22 times 7 is 154. So there I've taken 3 logarithms and condensed them into one. Well, a natural log is just a log. But so they have the same rules. But we should, before we try to condense them, we should go ahead and move that 4 up into the exponent there. And then I can condense them. Remember, subtraction turns into division, so that's going to be x divided by y to the 4th. Like that. All right, one more condensing, and it's addition, so we're going to change it into multiplication. But before I do that, make this log of u to the 20th power, just move the exponent from the front back into the exponent, plus log of v to the 5th. And now I'll be able to make this into one log by way of division. And on the top of the fraction in the numerator is going to be u to the 20th, and in the denominator is v to the 5th. Like that. And that's how you condense that. So in class, we did 3 things. We expanded, we condensed, and now I want to show you a little bit more how to solve. In my last video, we did some solving with logarithms, but they were a little less complicated than this. I just want to make sure that we're comfortable with solving all kinds of logarithmic functions here. So, on these guys, we've got log base x plus 13, 729 equals 3. Now, it looks complicated, but I want you to remember your rules, that how to switch between exponentials and logarithms. So remember that y equals b to the x and x equals log b y. We use these little rules to rewrite this logarithm. So what's the base? The base is x plus 13. Base is always the base. And then, let's see, after that, what goes to the base is the x. So that 3. So x plus 13 to the 3rd power equals 729. Now we're supposed to solve this for x, and probably the easiest thing to do is take the cube root of both sides, which gives me x plus 13 equals, well, let's see, cube root of 729. 729, there's one right there. Is there any others on here? There it is. 9 to the 3rd power is 729. So the cube root of 729 is just 9. because 9 to the third power is 729. So we got x plus 13 equals 9. Subtract that 13. X equals negative 4. Okay. Next up, log base 4 of 1/16 equals x minus 5. So we're going to write the base first. 4 to the power of x minus 5 equals 1/16. And we need to solve this thing. Now, when I'm dealing with exponentials, I find the easiest thing to do is try to get the bases to be the same. So I've got 4x minus 5, and I know that 16 is just 1/4 squared. But that doesn't make the bases the same. What will make the bases the same is we go 4 to the power of x minus 5 equals 4 to the power of negative 2. That makes this exponent of 4 squared, it makes it the reciprocal, so it puts it in the denominator. When your bases are the same, then you can just set the exponents equal to each other. So we've got x minus 5 equals negative 2. Of course, you add 5 to both sides to get x equals 3. That's it. Okay. Let's do one more. Last one. Let's solve log base 6 of 3x minus 3 equals 3. We'll start with the base. 6 to the exponent of 3 equals 3x minus 3. Let's see, 6 to the third power, I don't know that off the top of my head, but I do know that 6 to the third power on this power table is 216 equals 3x minus 3. And then if I add 3, 219 equals 3x. And that means that 219 divided by 3, that's a 79 equals x. Whoops, that was some bad mental math. What I meant to say is 73 equals x. Sorry about that. And that's it. That's how you're going to solve these guys. Thank you for watching. Hopefully it was helpful to you. Have a good day.